Can you able to see now?
Yes, sir, we can see it, sir.
PPT on the screen?
Yes, sir.
Yeah, good. Okay, right. So good morning, friends. So welcome back. Now we'll start with the mechatronics class. Now I think last class we have completed the module 2, which is mechatronics and microprocessor. Okay, right. Now we shall continue with the module 3. Now in the module 3, the part that I am interested to talk is on what is called as integration. Okay, right. Now before we go further, let's have a look at the content of module 3. Okay, the content of module 3 is having two different subheading. One is the programmable logic controller, that is PLC. Other is what is called as the integration. Okay, now I'm just starting with integration. Let me complete this integration chapter and then go further for module 4, skipping this. Okay, we'll come back to this program PLC and we'll have this PLC a little bit later. Okay, so some other concept is required for me to do PLC, so hence I am just postponing this. So as of now we'll proceed with integration. Okay, now in the integration chapter we will understand what is the background of this subject is, and then we'll understand about the advanced actuators. Okay, advanced actuators, and then the pneumatic actuator, industrial robot, different parts of a robot, controller, drive, arm, end effector, sensor, and functional requirements of a robot. Okay, so this is the content of this particular chapter. That is what we'll be doing, what is called the integration. Okay, right. Now let's start with the concept of integration. Now before we go with the integration, let's understand what is the necessity of this integration is all about, is important. Okay, right. Now when we have discussed in the first chapter, okay, in the beginning first chapter, we have discussed something called a system. If you remember, we have discussed what was called as the system. System is nothing but a black box which is having some input, and processing is going to occur, and you are going to get a corresponding output. Okay, now in case of a mechatronic system, basically you will be having a combination of systems are going to be present. Okay, a single system, remember, a single system will not constitute a mechatronic system. Okay, a single system will not constitute a mechatronic system. It is the combination of system. It is the combination of system which makes a mechatronic system to function. Okay, when I say a combination of system, which are the combination of system that you can think of? What are all the various systems that might be present in a mechatronic system? Can we have your observation? Can I have your observation here? Which are the different types of the mechatronic system which are going to be present? Take an example of CNC machine. Okay, take an example of CNC machine. Okay, in CNC machine, it's a mechatronic component. Okay, are you having only a mechanical system? Yes, please. Are you having? Hello? Is I audible, first of all? Is I on mute? Please kindly let me know. Or you are on mute. Is it audible to you?
Yes, sir.
Yeah. Then why can't you talk? In a CNC system, in a CNC machine, is the whole CNC machine consists only mechanical system? That's all. Simple question. Yes or no?
Yes, sir.
It's only mechanical system you have?
Mechanical and electronic.
Okay, which are the other systems that you are going to have along with mechanical system? You do have the electrical drives are going to be present. So you will be having electrical system. Then the machine control unit is going to be there, which runs the program. So you have what is called as the computer system, right? Then you have what are called as the hydraulic motors are going to be present. Okay, you have hydraulic systems, right? So means to say, when you are going to have a particular system, you will be having, or a mechatronic system, you will be having more than one type of systems are going to be present. Now what is required is, okay, now integration is nothing but how well you are going to understand the individual components of those system, and how well you are going to integrate. Okay, how well you are going to integrate is the concept that we are going to discuss in this chapter. That is, integration is a process of incorporation of methods, tools, subsystems, and ideas in an optimized manner. Okay, that means once you are going to have a system, okay, a particular system, this system is going to contain, this system contains a system from mechanical background, electronics, electrical system, okay, and then computer system, instrumentation and control, okay, right, and control algorithms. Okay, now from all this, you are going to build what is called as a complete mechatronic system. Okay, so now in order to have the effective, in order to have the optimized function, so requirement is how well you are going to integrate. Okay, how well you are going to integrate this system is what is important. Okay, therefore, right, it is required for, okay, it is required for what, this integration concept is required for integrating the software, okay, the hardware, tools, methods, and techniques that is going to be present in mechanical system, okay, electrical system, okay, or electronic system, okay, or computer science system or computer based system, or instrumentation and control. Okay, in all these you are having software, you are having hardware, tools, methods, and techniques. Okay, now how well you are going to integrate between them, okay, how well you are going to integrate between these is what is the concept of integration. Okay, hope I have given. So basically integration is nothing but understanding what is present in each individual system and get the maximum benefit out of the individual components. Okay, now integration is nothing but going together or taking the importance of all the components together. Okay, now that is the basis of what is called as the integration. Okay, right. Now let's understand the introduction and background. Okay, now the following list highlights some of the features. Okay, some of the features the mechatronics control system should satisfy for integration purpose. Means in order to do the integration, okay, integration is nothing but connecting, simple, as simple as that. Okay, so integration, I told in the very beginning, the definition of mechatronics, if you remember, definition of mechatronics is it is a synergistic integration. Okay, remember, it is a synergistic integration of mechanical discipline with the other discipline, okay, in order to process or in order to manufacture the components. Okay, now integration is nothing but combining, or integration is something but basically what is called as utilizing or connecting the various different disciplines. Okay, now the following features should be present, okay, in order to make the mechatronics control system for the purpose of integration. Okay, now it says interlock checking. Okay, please understand carefully. Okay, interlock checking. Okay, so just put a comma here. Okay, interlock checking, it says before any movement, the current position of related mechanical units must be determined, okay, to avoid collisions. Okay, what does it mean? Okay, what is the meaning of interlock checking? Okay, so the definition of interlock checking is before you do any movement of the object, the current position of the mechanical unit must be determined. Okay, now means let's say, okay, let's say you have a one particular component present here, another component present here. Okay, right. Now this is the current position. You need to move this component somewhere here. Okay, right. Okay, this is your next second point. Okay, and from here to here. Okay, and you need to move the component somewhere here. Let's assume. Okay, right. Now, what is the meaning of interlock checking is? What is the meaning of interlock checking is before any movement, before you move these two components, first check what is the current position of it. Okay, what is the value of x of this? I am taking only two. Okay, let me take all the three. What is the value of x, y, z of this point, and what is the value of x, y, z of this point? Okay, why you are required to know this is once you are going to move to the next location, okay, there should not be what is called as a collision. Okay, right. Let's assume that there is, okay, let's assume one point here. Okay, right. So one more point is somewhere here. One more the unit. Let's say, okay, one more unit is present here. Okay, so this is called as unit A, and this is called as unit B. Okay, right. Now, while moving unit A, okay, while moving unit A, you should remember that there should not be any clash, okay, onto this unit B. Therefore, remember where exactly the current position is going to be there. When you are going to move the object from current position to the next object, there should not be any collision of the objects. Okay, there should not be any collision of the object. That is what is the meaning of interlock checking. Okay, check the current position in order to so as to avoid any collision. Okay, right. The second one is called as timeout checking. Okay, now timeout checking is nothing but what? If a mechanical drive unit, okay, if a mechanical drive unit has not completed its movement or cycle, okay, now for every completion of the process, okay, that is what is called as a time indicated. Okay, simple. Okay, now for every operation, there is going to be a specific time indicated for the completion of the operation. Okay, now timeout checking is nothing but, okay, timeout checking is nothing but whether the operation has been completed within this specific amount of time. Okay, whether the drive unit, okay, whether the drive unit has completed the operation within this time t1. Okay, if not, okay, it took some t1 plus some time. Okay, t1 plus some time, then how do I know, okay, that it has taken some extra time? Okay, therefore this timeout, some error, okay, some error has to be thrown. Okay, some error has to be thrown to you, or some error has to be displayed, okay, which says that so it has took extra amount of time, okay, than intended. Okay, that is called as your timeout checking. That is, in the first one, in the interlock checking, you are making sure that there should not be any collision of the object when you move the object from one point to another point. Okay, in the second point, you are making sure, or you are telling that there should be an error message. Okay, there should be an error message whenever the mechanical drive, or whenever any of the drive, okay, which has not completed the cycle, okay, within the cycle, if it has not completed, then error message should be displayed. Okay, right. Then third one is the status display. Okay, status display. Okay, what you say, at each step in the sequence, an application relevant message can be displayed to the operator. That means you are carrying, let's say, status display on the monitor. Okay, now yeah, simple. Okay, let's say our the automobile itself. Okay, and the automobile panel. Okay, you will be having some different types of the display. Okay, that means might be if the oil has come down. Okay, or if it is going to be the fuel has reduced. Okay, or have you switched on your what is that? If you are not fasten your seat belt. Okay, remember, if you are not fasten your seat belt, some display is going to come. If if the charge has gone, okay, some display is going to come. Or if you are not, if you put the handbrake, some display is going to come. Okay, what does all those indication? Okay, all those indication, okay, is about the system that you are using. Okay, now what, that is nothing but your status display. Okay, status display says at each step in the sequence, okay, at each step in the sequence, an application relevant message can be displayed to the operator. Okay, if it is so, okay, if the status display is going to be present, it is easy for the operator to know what is happened with that particular system. Okay, let's say in an what is that, in an automatic washing machine. Okay, so some display is going to come, whether it is going to be in the pre-wash cycle, or whether it is in post-wash cycle, or whether the what is that, the machine is operating in the rinsing cycle, like. Okay, so there are some buttons are going to be there. You can able to understand by looking at the buttons. Okay, you can understand what is the current state of operation of a particular equipment or a particular device. Okay, it makes the operator to understand. It makes the operator to understand where is the status, where is the current status. Okay, so if any status has missed out, or if anything has happened, it will be known to him. Okay, that is about the status display. Okay, then next is error messaging. Okay, now similar to the status display, as you expect, in each status, for each status, you want the operator to be notified about what is actually happening. Also you wish to know, is there any message, sorry, is there any error associated with that particular status? Okay, right? So error messaging is nothing but each step in the sequence has an associated list of messages, okay, to display when any error has been detected. That means if any error has been detected in each of the step of the operation, okay, so you expect there should be a display of the error for the purpose of making sure that the error is going to be nullified, or whether the error is going to be avoided in the next stage of operation. Okay, now these are the four cases. Okay, number one is interlock checking. Okay, interlock checking means in the interlock checking you are avoiding the collision by understanding where the position of the objects are going to be. The second one, timeout checking. If the drive system has not completed its intended operation in the specific amount of time, you want some information to be given. Status display. Okay, so for each of the operation, there should be a relevant display to the operator indicating what is the type of operation that you are undergoing. Okay, then error messaging during each step. Okay, if there are any messages, if there any error is going to come, those error messages should be told to the operator. Okay, now these four features are required, okay, in order to make sure, in order to satisfy the mechatronic control system for the purpose of integration. Okay, means in order to integrate the components, in order to integrate the various different components in your mechatronic system, you should supposed to follow these interlock checking, timeout checking, and then the status display and the error messaging. Okay, so this is about the first one called as the introduction and the background. Okay, right. Now along with this here, the four different types. Okay, is a besides real-time performance and the cost per components, there are other two factors to be considered. Okay, now these are the following two additional factors, okay, to be considered, okay, while integrating the machine system. Okay, while integrating, please consider these two also. Okay, what are these two? Ability to change the number and type of control components on a particular machine, okay, in order to easily modify or extend its functionality. Okay, right. What does it mean? Okay, ability to change the number and type of control components. Okay, the number of control components are a type of control components. Okay, right. Now just a simple thing. Now it is going with some functionality. Let's say a particular component is going to be there. Okay, so you have designed this component. To do certain functionality. Okay, right. You want to add some more feature to it. Okay, let us say that you have an automatic washing machine which shows the display for some 3 items. Okay, that is what is the amount of water present in the pump. Okay, what is the temperature present. Okay, and what is the time left out, okay, for the complete operation. Now this one more is there. Okay, right. Now one more feature you want to add. Okay, please understand. So you have already 3 features are going to be there. So for these 3 features, some control algorithms has been written in order to make these 3 features to function. Some control algorithm has been written. Okay, now you want to incorporate one more feature into it. Okay, if you want to incorporate one more feature into it, what is that you are doing? You are modifying the functionality of the device, or you are extending the functionality of the device. Okay, if you want to add or extend the functionality, is your system is capable of taking that into account? Okay, is it altogether new setup you need to make, is the question. Okay, if you want to make a new setup, then what is going to happen? Then this is going to become fixed. Okay, so this is going to become obsolete. Okay, so you can't do that. Okay, so some extra feature to be added to the same setup. Okay, so that should be possible. That means ability to change the number and type of control components. Okay, it should be possible for me. For the integration of machine system, it should be possible for me to add more number of control components. Okay, some other type of control components on a particular machine. Okay, so as to go further. Okay, so that is the one thing. Then the next one is ability to individually configure. Okay, ability to individually configure and test components of the machine before they are combined together. Okay, Now what it means? Ability to individually configure and test the components. Okay, right. Now you have so many different components are going to be there. Okay, which makes up a one particular system. Okay. Now testing of this is one part. Okay, so before you are going to test this particular component, make sure that these individual components, okay, which goes into the main system should also be tested. That means what? Ability to individually configure and test components. That means what? In your machine, in your CNC machine, you have the guideways, okay, you have the ball bearings are going to be there, or recirculating ball screws are going to be present. Okay, you are going to have a stepper motor. Okay, right. Now all these individual components, okay, all these individual components should be configured. Okay, you should be able to configure the individual component, and also you should be able to test the components of the machine before they are combined together. Okay, before you combine them together to call it as a complete CNC machine. Okay, before you are going to combine and call it as complete CNC machine, you should be able to configure and test the individual components which goes into that particular assembly. Okay, now these two are an additional requirement. Okay, additional factors which is required for the purpose of the integration of machine system. Therefore, now the concept says what is this? The background says the four different the tests. Okay, interlock checking, timeout checking, status display, and error message. Along with these two, okay, is required for the purpose of integrating the machine systems. Okay, right. Now with this simple background, okay, now we'll go further. We'll understand what do you mean by advanced actuators. Okay, right. Now we'll try to understand the difference between a standard actuator and an advanced actuator. Okay, right. Now you know at this stage that so there are three devices are going to be required, or three elements are going to be required in order to make up a mechatronic system. The first one was the sensors or transducer, second one was the controller, third one was the actuators. Okay, right. Now let us talk something related to the advanced actuators. Okay, right. Actuators are important control devices, okay, because they are the one which actually does the work told by the controller. Okay, controller will give the plan. The implementation of the plan is going to be done by using your actuators. Okay, actuators are used in a very wide variety of applications. Their function is to produce rotational or linear movement. Just remember, any system which moves, okay, comes under an actuator. Okay, anything which moves in your system are all called as an actuator. Okay, the movement might be rotational in case of a cam, or in case of your the rack and pinion, linear to linear to rotary, or that might be a gear. Okay, it's a rotational movement, or it might be a simple linear movement also. Okay, right. Now the basic actuators may be, okay, the simple actuators might be a switch, okay, a general switch, or a valve in your hydraulic or pneumatic system, or might be an electrical motor, which might be a pneumatic case or an hydraulic type. So these are the basic actuators. Okay. Now there's one diagram which is going to be there. It says about how a paradigm shift has been occurred as far as the development of advanced actuators are concerned. Okay, what is this paradigm shift? Okay, with respect to the advanced actuator, we'll try to understand. Okay, right. For a moment, forget about the right hand side. Okay, forget about the right hand side figure. Okay, now just observe this. Okay, what do you mean by an advanced actuator here? Okay, so that is simple. Okay, in your not the advanced actuator, a standard actuator. Okay, what is the standard actuator? The standard actuator is the one. There will be something called as a control algorithm. Okay, means control algorithm has been developed by what? Developed by a device called as the controllers. Correct? Okay, control algorithms have been developed by what are called as the controllers. These controllers might be your microprocessor, or this controllers might be microcontroller, or this controller might be your programmable logic controllers. Okay, So you have been given an algorithm. Okay, algorithm is nothing but some set. Okay, this is how you need to do. Okay, right. So I have told some control algorithm. Okay, that might be a open loop or a closed loop. Okay, generally it is going to be a closed loop only. Okay. Now based on this control algorithm, please understand, based on this control algorithm, you are going to carry out the work. Okay, that is the job of a standard actuator. Okay, as a standard actuator, I am only listen to what my algorithm is going to say to me. According to the algorithm, I am going to carry out my intended operation. That is the job of a standard actuator. Okay. Now, will this standard actuator is going to be still there in the current context is important. Okay. What is that we are trying to say is there is a shift, a paradigm shift. Okay. There is a transition which has occurred from the standard actuator to an advanced actuator. Okay. Now, in order to call any actuator as an advanced actuator, what are the other features that you should supposed to have? Okay. So, number one, control algorithm, basic feature you have to have. Okay, without control algorithm, nothing you can able to do. Remember, without control algorithm, you can't do any work at all, because somebody has to tell you some work to be done. Okay, so if nobody is going to be there, then whether it is a standard actuator or advanced actuator, it is going to be useless only. Okay, so therefore control algorithm is going to be common. Okay, here also was control algorithm was there, obviously. Here also it is going to be there. Then what beyond? What beyond? What is beyond control algorithm? Okay, we are very important called as the condition monitoring. Okay, you have what is called as condition monitoring. What do you mean by condition monitoring? Any idea? Just can anybody say what do you mean by condition monitoring? Can anybody say what do you mean by condition monitoring? Hmm? Yeah. What you do in condition monitoring? Rajwal Patil?
I do not know, sir.
No, you make it out. What condition monitoring?
Based on a condition, it monitors something.
Okay, what is the condition monitoring of a human being?
There are many conditions. Example, you asked me a question, so I responded to it. It is
Okay.
also condition monitoring.
Okay. Then any other?
Suppose like in the morning, as soon as we get up to hygiene ourselves, we take bath. That's also condition monitoring, and many other such things.
With respect to machineries, what do you mean by condition monitoring?
We have to make a certain product. We have to make, say, from a cube, we have to convert it into a rectangle. So we heat it and then beat it to its required dimension. Until that dimension is achieved, we keep hitting it. That's also condition monitoring.
Okay. Any other answers?
So can we say condition monitoring in terms of temperature at which the machine operates,
Okay.
or the speed at which the machine is operating, these factors as such?
Okay. Any other? Condition monitoring. Condition monitoring of a machine. What does it mean? Simple. Okay. Condition monitoring of a machine. Let's say. Okay. Now, if you observe. Okay. Now, what is the intention of this slide is? Now, first one is control algorithm. Second one was condition monitoring. Basically, condition monitoring is a process wherein you are going to check the health of the machinery. It's very simple. Okay. Condition monitoring is a process of checking the health of a machinery. Okay, like if we intend to check our health of a machinery, okay, health of ours, okay, we want to know what is the condition of the various different parameters. Okay, right. Now we go to a diagnostic center. Okay, so in diagnostic center, he is going to take so many parameters and he will give so much is this, so much of this, so much is this. Okay, so you can have some fixed values. Okay. Now similarly, now condition monitoring makes sure that your machine. Okay, make sure that the machineries which are going to be present are behaving properly. Okay, are behaving properly, are not giving any undue problems to you when you are going to operate. What is going to happen? So there is something called breakdown maintenance. If you might have heard of. Okay, what do you mean by breakdown maintenance? Say very simple. I am having a bike. Okay, so I have purchased very long back. I don't want to repair it very oftenly. Okay, I don't want to take that to a garage. Okay, right? So what I will do, I will just keep on riding it, keep on using it. Okay, till what? Till what? Till what? Till it is going to fail. Okay, I will not repair till it is going to fail. Then I will start go for repairing. Okay, this is what is called simple. I am giving a simple example. This is called as a breakdown maintenance. Means allow the machine to break. Allow the machine to break. Then you go for repair. Okay, that is a particular type of maintenance. Okay, but that cannot be taken for all the machineries. Okay, because once it is going to, once there is a breakdown, then what might happen, a larger amount of issues will come into picture. Okay, so that you can't able to check it out. Okay, now for that we have what is called as condition based maintenance. Okay, there is something called as condition based maintenance, or we also call it as preventive maintenance. What do you mean preventive maintenance? Preventive maintenance is simple. Before something is going to happen, you take the care today only. Before some problem going to come tomorrow, take the precautionary measure. Okay. Now taking the precautionary measure, okay, or understanding the parameter and taking the precautionary measure is an aspect of what is called as condition monitoring. Therefore, condition monitoring is a process wherein you are checking the vital parameters of the performance of the machine. If the vital parameters are all good, the condition of the machine is good and you need not to worry. Everything is fine. If the vital parameters, okay, if the hemoglobin level is lesser, okay, if the glucose level is lesser, okay, or if the glucose level is higher, okay, or the creatinine is higher, something like that. I'm just giving an example. Okay, so it says what? It says about there is some problem is going to occur in the near future. Okay, so then you take the precautionary measure today so that the future is going to be safe for you. Okay, so that is what is called as condition monitoring. Then the purpose of condition monitoring is what? The purpose of condition monitoring is to check what is called as the fault. Okay, so the very requirement of why you do condition monitoring is there any fault which is going to be there in the machinery. Okay, so now the later stage is fault detection, okay, and isolation. Okay, what is a fault detection? Fault detection is okay, fine. Okay, that means what? You have took the reading from a thermocouple reading says, okay, so remotely you started to take the temperature reading. Okay, so now from the morning till evening. Okay, so somewhere at 6 p.m. okay, you observed that the temperature is going to be somewhere which is 450 degrees Celsius, which is not warranted. Okay, right. Then what you need to understand here is by observing this temperature, you need to immediately come to the conclusion that so this is not in our, it is not in the range, it is going beyond the range. That means there is some fault has occurred. Okay, some problem has occurred in the machine. So now by proper condition monitoring, you could able to detect the fault. Okay, now next thing is, okay, is our job is only to detect the fault and leave as it is the question? Definitely not. What for we are doing, once we identify the fault, we require to address that fault. Okay, so that is nothing but what? Isolation. Okay, isolation is nothing but it is not addressing the fault. Remember, isolation is not addressing the fault. Isolation is nothing but nullifying the fault. Okay, so there should not be any fault at all. That means you identify the fault, you detect the fault, and make sure that it has been completely isolated, completely removed, okay, from the machinery. In order to do that, okay, you should do what? You should do some prior testing. So based on the prior testing, you identified the fault and then you are going to isolate the fault. Okay, now these are the important thing an advanced actuator should supposed to have now. Okay, now that is what I have told. There is something called as a paradigm shift has occurred from the simple so-called only control algorithm to control algorithm plus condition monitoring plus fault detection and isolation. Okay, now Now this requires, okay, this condition monitoring, this fault detection and isolation requires some circuitry, some mechanism, okay, some electronics to be required. Okay, now those are going to be given by what are called as your microelectronics. That is the thing but what is called as MEMS, okay, micro electromechanical systems. Okay, so through the concept of MEMS, okay, you are going to bring microelectronics into the actuator. Then digital systems. Okay, now nowadays you are not at all using what is called analog system. We are in the era of digital system. Okay, so now digital system makes the display looks much more attractive to you, okay, much more pleasing to you, and much more easy for you to understand, and it is easy to read also. Okay, digital system. Okay, then distributed control, that is how you are going to control the advanced actuator. Then open standard is something but for the purpose of developing an actuator. So open standard makes sure that everybody can able, it is like your the open source softwares, okay, right? So you can have an easy access, okay, easy access to develop the advanced actuators, okay, right? So now this is something related to what is called as an advanced actuator. The figure indicates how the paradigm shift has occurred in order to have a feel of an advanced actuator from what is called as a standard actuator. A standard actuator is this. Then advanced actuator will consist of control algorithms, then condition monitoring, then fault detection and isolation. And to support this activity, there should be a microelectronics embedded into the system, then digital system, distributed control, and it should follow what are called as open standards. Okay, now this is the advanced actuator. Okay, question might be, how can you have, okay, the question might be like this. Okay, your innovative question may be like this. Okay, so in a way of development of an actuator, okay, you are interested in developing an advanced actuator. Okay, which are the various components, okay, you wished the advanced actuator should supposed to consist of. Okay, now explain. Okay, now rather than asking a simple question like with a neat block diagram explain advanced actuator, I put a question like this. Okay, then you will be writing about all these cases. Okay, so it's about an advanced actuator. Okay, right. You can observe a standard actuator in its basic form only consists of control algorithm. However, advanced actuator integrates auxiliary features such as condition monitoring, fault detection and isolation scheme, digital technology, distribution controls, and open standard. Means all this will make the advanced actuator to happen from the standard actuators. Okay, right. Now, how this advanced actuator is going to be? Okay, we'll take some small example. Okay, right. Now, one of the advanced actuator is this. So it is advanced smart motorized actuator. Okay, so some working of a motor will look into. Okay, working of an electric motor. What are the vital parameters of the electric motor that we'll try to look at? That is about the advanced smart motorized actuator. Okay, so how the smart actuators is going to be. Okay, now an example was electric motor. Okay, so for an electric motor to perform efficiently, okay, an optimal match of the motor and the drive system must be achieved. Okay, so now second line, performance of the motor can be improved by monitoring the condition of the actuator online. Okay, actuator online. Okay, now remember there are two things which are going to be there. One is called as online monitoring and offline monitoring. Okay, now you can clearly observe the basic difference between online and offline monitoring. So once I say online monitoring, okay, remember online monitoring is nothing but the work is running, means the machine is running. When the machine is running, you are going to take the vital parameters of the machine without stopping the machine. Please remember, you are going to collect the vital parameters of the machine without stopping the machine. That process of condition monitoring is called as online condition monitoring. There is something called as offline condition monitoring. Okay, so offline condition monitoring is something but you stop the machine. Okay, you stop the machine and then go for repair. That means what? Now if you just observe in some of the company, they are going to have some time for maintenance. Okay, so during that maintenance, okay, they are not going to operate the machines. Okay, now they will just close off all the work. Then thorough maintenance, okay, they are going to do without being without being running the machine. So now whatever you are going to do nowadays, we are not going to do any offline monitoring. Remember very clearly, very important. Nobody wish to stop the machine for a minute. Nobody wish to stop a machine for a minute. Okay. So therefore, ruled out is offline monitoring. Always it should be online monitoring. Machine should go on, and you should you should place the sensors wherever it is required and take the information and analyze whether everything is fine or not. Okay, right. Now, condition monitoring, as I said previously, condition monitoring attempts to identify the faults. Electric motors can be monitored by the use of physical parameters such as means the in order to assess the performance of the electric motor, the voltage requirement is there, means the value of voltage I need to know, current, speed of the motor, magnetic flux, whether it is a viscous friction or whether it is a dry friction, that I want to know. Okay, now this block diagram will give some understanding about what is called as the advanced actuator about. Okay, now just observe. Okay, so now all these are parameters. Just observe. This is the list of parameters. Okay, this is the list of parameters. Which are the parameters? Voltage, current, torque, temperature, magnetic field, speed. Okay. Now I need to analyze these parameters. Okay, I need to analyze these parameters. Okay, in order to analyze these parameters, from where are you going to get the information? Okay, so you want to know the voltage level, you want to know the temperature level. Therefore, the requirement is some measurement device required. Means sensors or the actuators are required. Okay, now this is what is that I wrote here. In order to measure these parameters, I am having the machineries, or I am having a measurement device. Okay, voltage or current measurement device. Okay, so voltmeter, ammeter is there. Torque meter you are going to use. Temperature sensors you are going to use. It might be a thermocouple, might be a thermistor, might be a resistance temperature detector, that is RTD. Anything. Okay, some temperature sensor you are going to use. Then I want to know magnetic field. Okay, therefore I will use all effect sensor. Okay, I want to know the speed. Okay, of rotation. I am going to use encoder. This encoder might be an absolute encoder or incremental encoder. Okay, right. Now these are all the devices which measures this. Now what is I am doing? Okay, I am using the word called as data fusion. Okay, I am using the word called as data fusion. What is it I am doing? I am collecting all the information. Okay, I am collecting all the information and I am analyzing the fault. Okay, fault analysis based on comparison of characteristic and physical parameters using measurements. Okay, now remember here I am having a knowledge base. Means knowledge base is nothing but what? It's a database which is already present with me. Knowledge base is a database which is present with me, which says about what should be the what should be the speed, what should be the magnetic field, what should be the allowable temperature, how much torque it should withstand. Okay, right. All is going to be present in my knowledge base. Okay, so now I am having a knowledge base which is a comparable parameter. Okay, now from here you just check with this. Okay, so compare the temperature what you have measured with the temperature what it should have been. Okay, then if there is any difference is going to be there, then you are going to perception. Okay, then you are going to decide, okay, what is the problem. Okay, then accordingly you take the call whether some problem has, whether the problem has occurred with the temperature, or whether the problem is with the encoder, or whether with the voltage meter. Okay, means this is indication of how the collection of the information is going to help in order to make the effective decision making during the building of a advanced actuator. Okay, is what is that all this about. Okay, right. Now you can observe the physical parameters are measured online. Applying sensors for measuring the position, speed, torque, voltage, current is possible to estimate the characteristic parameters from the physical parameters online. Okay, now you can observe here. Now online estimated parameters. Estimated parameters are nothing but the measured parameters. Okay, are compared with the stored parameter. Okay, which have already been obtained from your data sheet. Okay, now this stored parameter is nothing but what? Is nothing but your the knowledge base. Okay, so the stored parameter is nothing but your knowledge base. Then what you are measuring is your estimated parameter. Then you compare this with this to understand whether everything is going on fine or not. Okay, so this is about what is called as the concept of your the advanced actuator, and a subsequent example for the advanced actuator, which is nothing but the working of a motor. Okay, right. Now we'll come back to this later tomorrow. Okay, so before I close off, okay, let me just give a brief about right. The second test you will be from, it will be from 5th, 6th and 7th. Okay, if I'm correct. Okay, so right now the portion for the first test what we have covered is up to what is called as eddy current braking system. Sorry, eddy current proximity sensor, if I am correct. Yes or no? Yes, yes or no? Okay, please make a
Yes, sir.
okay, so eddy current proximity sensor. Okay, so we are done up till the eddy current proximity sensor. Okay, the nodes of the sensor I think I have given completely, if I am correct. Correct or what?
Yes, sir.
Okay, right. The sensors nodes I have already given. That is sensors and transducers. So we are done up to eddy current proximity sensor. Then you are going to study from here onwards. Okay, which is capacitive proximity sensor. Okay, capacitive proximity sensor. Then photoelectric proximity sensor. Then 3 different types of light sensors. Then encoders. Okay, so that is a small portion left out in your the sensors and transducers. Okay, then you are going to discuss what is called as the module number 2, which is your the microprocessor and microcontroller. Okay, complete portion of microprocessor and microcontroller, and whichever the portion that I am going to do up till tomorrow. Okay, so up till tomorrow, because after that also I am going to get one more class. Let us not take that. So up till tomorrow, whatever I am going to do in this particular chapter. Okay, so up till there it is going to be present. Okay, so now today I will just pass on the microprocessor and microcontroller notes, and tomorrow I will pass on this particular chapter notes. Okay, right. So this is about the portion for the test. Okay, right. Then is it clear now? After eddy current braking, after eddy current proximity sensor. Okay, so after eddy current proximity sensor, from pneumatic proximity sensor, capacitive and all that. Okay, right. So that is about the portion. Then let's come back to your the case study and summative question. Okay, I think I already pointed out when I am doing microprocessor and microcontroller. Okay, right now when the question might be like this. Okay, when the microprocessor is carrying out its intended operation. Okay, when a microprocessor is carrying out an intended operation, some external device wants the attention of the microprocessor. Okay, right. What process are you going to adopt, okay, in order to drag the attention of the microprocessor? Okay, I am going to frame like something like this. Okay, so what is that you need to do? You need to write here. There is something called as a concept called as interrupt. Okay, so there is something called as a concept called as interrupt. Basically, interrupt is what? Interrupt is something but if you want to have a attention of the microprocessor when it is carrying out the task. Okay, then you are going to use this interrupt. That is one thing. Okay, then question number 2 is you have completed the operation. You have completed a mathematical operation by using arithmetic logic unit. Okay, so question is like this: arithmetic logic unit is used to perform mathematical operation in the microprocessor. Okay, right. I want to know what is the status of the mathematical operation performed recently. Okay, remember, I want to know what is the status of the mathematical operation performed recently in the arithmetic logic unit. Full stop. Which type of register is going to be used? Okay, which type of register is going to be used in order to know the status of the operation of arithmetic logic unit? Okay, right. The answer is the status register, or it's also called as the flag register. Okay, if you remember, 5 flag registers I have discussed. Okay, that is sign flag, zero flag, auxiliary carry flag, and parity flag. Okay, so by using this, okay, I think I have also given one particular example, okay, to show how the flags are going to be determined. Okay, so with an example you may have to explain this. Okay, right. Then next is going to be, now I want to go for, okay, I want to build a mechatronic system which integrates, okay, I want to build a mechatronic system which integrates the various subsystems. Okay, please understand, I want to build a mechatronic system which integrates various different subsystems. In order to make the integration to happen, which are the parameters or which are the factors, okay, it should be present. Okay, explain the factors for the integration purpose. Okay, now if you observe here, so this is my question that I have framed. Okay, right now here the following list highlights some of the features, okay, which the mechatronics control system should satisfy for integration purposes. Okay, I will frame something like this. Okay, in order to satisfy the integration purposes, which are all the factors to be considered. Okay, so these 1, 2, 3, 4 and added to this. Okay, right. Then question number 4 is regarding the advanced actuators. Okay, now what are the components of an advanced actuators? Explain. Okay, if you want to design an advanced actuator, what are the factors which you like advanced actuator should supposed to have? Okay, right. So now this is for the standard actuator and this is for the advanced actuators. Okay, I think I have told 4 different questions. Okay, so which is going to be a part of your the innovative and case study. Number 1 is on the interrupt. Number 2 is on the flag register. Number 3 is on the integration factors. Number 4 was on advanced actuators. Okay, right. So go through with this, and if you got any clarification, you can reach out to me. Okay, right. So we'll stop at this stage now. Okay, we'll stop the class at this point. So let us close it off and give your attendance. Abdul Khalid Pasha. There are 30 members present on board. Okay, right. Pasha absent. Anil Kumar Master. Anil. Ankesh Aman. Vasuraj.
Yes, sir.
Chandan KN.
Present, sir.
Chetan Kumar. Chetan. Dheeraj.
Present, sir.
Himanka.
Present.
Himanka.
Present, sir.
Okay. Murali Kishan. Kunal Rajkiran. Yam Dhanush.
Sir, Murali Kishan present.
Okay, got it. Dhanush. Junaid. Mohammad Junaid. Shri Prasad. Niharika.
Yes, sir.
Nihar Venkat Sai.
Yes, sir.
Nilesh.
Present, sir.
Nirav.
Yes, sir.
Rajwal R. Patil.
Friends, sir.
Prince Stronger. Rishabh Prince.
Present, sir.
Rishabh Pandey.
Present, sir.
Rohan Kagalkar.
Present, sir.
Roshan.
Present,
Sagar. Okay. Sagar.
Present, sir.
Charanaya. Sheikh Manan. Shobit.
Present, sir.
Okay. Shobit. Siddharth Shankar.
Present, sir.
Siddharth Sridhar.
Yes, sir.
Subramania.
Present, sir.
Sumuk VR. Sumuk. Ulas. Vivian.
Present, sir.
Pawan.
Present, sir.
Shiva Krishna. Okay, present. Ranveer Singh. Dhanush Natampalli.
Present, sir.
Gautam Sai. Uppala Chanakya.
Present, sir.
You call me later.
Yes, sir.
Chimika,
Present, sir.
Shopavan,
Present, sir.
yeah. Abdul Khalik Pasha, where you are resign. Okay, right. So thank you all. We'll meet in the next class.
Thank you, sir.
Thank you, sir.